Okay, let's talk a little bit about scope, visibility, and lifetime. All right, let's start with some definitions. Scope is a compile time concept, and it has to do with where in code a resource can be accessed. Visibility is very similar, but not exactly the same. It's also a compile time concept, and it has to do with what the code looks like when the resource is actually accessed. A lifetime, on the other hand, is a runtime concept, and it has to do with how long the resource exists while the program is running. So let's use some code to demonstrate some of these concepts. So this will be out of the dynamic demo scope visibility lifetime that you see here. And note that I'm going to put all of this code in one file just to keep things easy to see. C# really doesn't have the concept of file scope the way some other languages do. So whether you put your resources in multiple files or all in one file, C# is pretty much going to see it the same way. All right, so let's go ahead and create underneath program a class called car. And we don't really need anything inside a car. We just need a class to work with. And inside of the class program, I'm going to create a private static car junker. Now this, of course, is a field in the form of a reference variable. Note that although I'm making my field static, it really has nothing to do with static per se. I could just as easily make this an instance variable, but main is also a static method, and so that's why I'm doing it this way. So all these things would still apply even if I was using a non-static field and a non-static method. All right, so we'll start with scope. I will create a variable I, and at this point I is in scope. It's visible, and it's placed on the stack. I could create a reference variable Hudson. So the reference variable Hudson is in scope, and in fact that reference variable is placed on the stack, but the object itself doesn't exist yet. Now when I actually create the new car, the storage for the object referenced by Hudson is then created and is in scope. Now imagine I were to call a method, and we can declare that method, and you'll see that method 1 has its own region of scope. And at this point, since I called method 1 from main, the variable I still exists, that is to say it's inside of its lifetime, but it's out of scope and it's out of visibility. I can't reference it from here. So the reference variable Hudson is also out of scope for the same reasons, and it is on the stack, and it's still in lifetime because it's still there on the stack, but again, it's not visible and it's out of scope. Now the object referenced by the reference variable Hudson is out of scope and visibility, but still exists, so it's still in its lifetime and it's on the heap. If I were to create a variable inside of method 1, that variable would then be in scope and visible and would be placed on the stack. And at the end of the block in which that variable is created, in other words here, J is now out of scope, it's not visible, and it's removed from the stack. And once we return from method 1 and get to the end of main, at this point, everything is out of scope and has reached the end of its lifetime. Probably the most important thing about the object referenced here by Hudson is that object exists on the heap. In other words, it's inside of its lifetime throughout the entire program as long as there's a reference variable pointing to it. So for example, let's say that we set junker equal to Hudson. So now, even if I were to go to another method, like say method 1 here, because junker is in scope for method 1, remember that Hudson is not in scope for method 1, junker is in scope in method 1, and the object that it references still exists on the heap, so I can manipulate the object that was originally pointed to by Hudson, even though the reference variable Hudson is out of scope and is not visible. So a couple things to note. References are a way to bring resources from other assemblies into scope. And when I say references, I mean these sorts of references here. These are other regions of scope that I have access to because I've created these references. We use namespaces essentially to name a region of visibility that you've brought into scope, whether it's because it's in your project or you've used a reference. And using directives change visibility. They don't affect scope per se, but they change how you refer to a resource when you're actually using it. So with using directives, things that are in scope, in other words, things we have access to, have direct visibility because we don't have to put the namespace in front of the resource. Without using directives, in other words, if we don't use them, then things in scope, things we have access to, have indirect visibility because we have to put the namespace in front of the resource in order to use it. So for scope and visibility, which is a compile time concept, for value type variables, the scope of the variable is the block in which the variable is declared. For reference type variables, the scope is whenever a reference variable references them, meaning the objects. For lifetime, which is a runtime concept, the lifetime of a value type variable is during the execution of the block in which that variable is declared. For a reference type variable, it's after allocation instantiation, in other words, using the new keyword, and as long as the reference variable is referencing the object storage on the heap. So value type variables reside on the stack, whereas reference type variables reside on the heap. It's not that the data structure that stores the variable or the object is necessarily that important. It's just that the way the stack is managed is different than the way the heap is managed. Things on the stack come and go as necessary. Things on the heap are there until we actively remove them. In the case of managed code, actively removing is a little bit different. It really just means that there's no longer a reference variable pointing to that storage. And that's scope, visibility, and lifetime.